When we're given a conic section in standard form, it's usually pretty easy to tell which type of conic it is. A circle, you can see the center and the radius right away. An ellipse, you see the denominators are different with a plus sign between them. A hyperbola, you might have different denominators, you might have the same denominators, but it has a subtraction sign between them. And a parabola is kind of in that vertex form. But when I have a conic section, in general form, it's a little bit harder to tell, but that's what we're going to talk about with this one. I have 4 equations, and each one represents a different type of conic section. Now, I'm going to actually start at the bottom and work my way up. This bottom one, do you see how I have an x squared, but no other squared term? Because only one of them is squared, that tells me it's a parabola. Okay. Next one. Again, I'm going to look at the squared terms. I have an x squared, and I also have a y squared. But if I look at the symbol in front of it, it's a minus sign between them. It does have a different coefficient, but that's not a requirement. It's this subtraction here, that guy, that makes this one a hyperbola. Now, next one. Again, looking at the squareds. Okay. I have a plus sign between them, and I have different coefficients in front. That means the distances that I'll travel along the x and the y will end up be different eventually. And so this is an ellipse. Last but not least, I have this top one. I look at the squareds. There's an addition between them, and my coefficient on both of them are 1. Now, I don't know how far I'm going to move, but the fact that they're the same means I'm going to end up moving the same distance. Since I move the same distance, that is a circle. And that's how we can tell from our general form which type of conic section it is. From any of those, we'd have to complete the square to get it into standard form to be able to graph it.